Hello ladies and gentlemen, today we want to look at transformations, another graphing techniques where we are going to look at shifts, which is translations, stretching graphs, and reflections. So in other words, we are going to look at how we can deform or form graphs from simpler graphs. So the objectives are to graph functions using vertical and horizontal shifts. And then you want to also graph functions using compressions and stretches. You also want to graph functions using reflections about the x-axis, the y-axis, the origin. And the key concept is transformations, which allow us to modify basic functions to create new graphs without plotting every point. So for example, we know the graph of y equals to x squared, which is shown by this blue graph. Then we can sketch from that function, we can then sketch this one, which is x squared plus 3, which is g of x. So if we sketch this graph will move upwards by 3 units. So here it was 0 and then here it will be 3. So this is every point in the graph will move up by 3 units. So it affects the y coordinate, which increases by 3. So this addition by 3 affects the y coordinate. So we call it a vertical shift. And then another example, if you are given this same function and then you are given x squared minus 4, the graph will be somewhere here. This is minus 4 and this is a downward movement or downward shift. Graph will move down. So the vertical shift rule is given by if you have got f of x and then outside f of x you add k. So this is a shift upward if you are adding. If you are subtracting is a shift downwards. So if you are given another graph, let me give you another example. If you have got this, if you know the graph of this and then you say plus half or 1, if you say plus 1, so this is a shift upwards of this graph, and then if you say minus 1 is a shift downwards of this graph, if you know the general sketch of this one. And then the horizontal shifts are inside x, they come inside there. If you know the graph of x squared and then the graph of x plus x, so this is a horizontal shift and this is a shift to the left by 2 units. So if you are adding, this is a shift to the left by 2 units on the horizontal axis. So similarly, if you are given the graph like this, and then the graph of y equals to 2x, it's supposed to touch there. So this will be minus 2, this one will be 4. So this is the graph of g of x equals to x plus 2 squared. So it's a shift to the left by 2 units of this general curve. And then if you are given this one, g of x minus 4, so this is a shift, it's a movement to move the graph of f of x 4 units to the right. So this is a shift 4 units to the right. So this is 4, this point is 4, and this is the graph there depicted by the red. So the horizontal shifts are counterintuitive. So meaning to say, if you have got a negative, you move to the right. If you have got a positive, you move to the left by the h number of units. And then combining shifts, so we can combine shifts. So you can see that this one, you can maybe start with this one. So this is a vertical shift. You move the graph 3 units to the left. So you start with the gray curve, which is your x squared. You move it to the left, you get your x plus 3 squared. So this is minus 3, right? And then this one is a vertical shift minus, you bring it down 5 units. So you bring this graph down 5 units. So your final graph is given by the blue one, which is f of x is equal to x plus 3 squared minus 5. X plus 3 squared minus 5. And then the stretch, if you are given the graph of f of x is equals to modulus of x, which is shown by the blue here. So if you have got g of x, which is 2 modulus of x, so yeah, this is a stretch. It's a vertical stretch. So this means that you are stretching, all the y values are multiplied by 2, so you get this red line. And then the compression, if you have got g of x is equals to half modulus of x, it's a shrink, so you are compressing the graph by half, so it will reduce the graph there, you get the green line. So it's more like you're multiplying the values of y by half. So the stretch and the shrink. So if you have f of x and you're multiplying it by a, so this is either it's a stretch of on the y-axis, or is a stretch, a vertical stretch on the y-axis. If a is greater than 1 is a compression, if y is less than 1. And then this is a horizontal stretch, which is inside. For example, if we had something like maybe say 2x, this is inside. This is an example of a horizontal stretch. So a horizontal stretch, if a is greater than 1, and a shrink is a compression if a is greater than 1, and is a stretch if a is between 0 and 1. And then the last thing are the reflections. So reflections, so about the x-axis. So if you are given f of x is equals to x squared and g of x is equals to minus x squared, so this is a reflection about the x-axis. So you take the x-axis as a mirror line, so you reflect each point. This one will come here, this one will come here, and so on. This one, when you're using the x-axis, so you reflect this using the x-axis. So you get this, and then the reflection about the y-axis. So the reflection about the y-axis, if you are given this, then it will be like f of x is equals to minus x squared. So this will be like a reflection about the y-axis, and clearly you can see that the sorry. Let me correct this. So yeah, so this is the squared is outside. So negative squared becomes positive x squared, and this gives you the same graph. So the reflection about the x-axis, the y-axis for x squared will give you the same graph. And then for this one, can try this one. If you know the graph of this, you can try this one and see what you will get. And then similarly, you have combination of you've got combination of transformations. Let's try sketching this one. Let's try sketching this one. All right, so let's go to the sketchbook. All right, so you have got f of x is equal to minus square root of x plus 1, square root of x plus 1 plus 2, plus 2. So here we start with f of x is equals to square root of x, which is a graph that looks like this. So this is a graph that looks like this. This is the graph square root of x. And then you say plus 1. So remember, plus 1 is like f of x plus 1. So which gives you x plus 1 like this. And this is a graph where you are saying I am shifting the graph. This is a horizontal shift on the opposite direction, remember. So by 1 unit, so instead of the shift to the left by 1 unit, so this is a shift to the left by 1 unit, so this minus 1, minus 1, so this is the graph of x plus 1. And then from there you can apply the reflection. X plus 1 is equals to minus square root of x plus 1. So this is a reflection about the, so this is a reflection about the one. Say this is a reflection. Oh, where is the reflection? So this is a reflection about the x-axis, a reflection about the x-axis because it's outside. So it's a reflection about the x-axis. So if it's a reflection about the x-axis, means that I'll get the same graph, means that I'll get the same graph minus square root of x plus 1 because this point will be reflected there, this point will be reflected there, this point will be so I'll get the same graph. I'm reflecting about the x-axis. And lastly, we say plus 2, and lastly we say plus 2, so plus 2 f of x minus x plus 1 plus 2. So this is a translation, so is the shift upwards by 2 units. So meaning to say the graph this graph will be taken up by 2 units. So it will be the very bad graph. This is a very bad graph. I try to draw a nice graph. Yeah, something like that. Remember, this is square root of x plus 1 plus 2 So when x is 0, this will be 3, this will be 2, and the graph should cut somewhere. When y is 0, this will be 0 equals to minus x plus, so I'm computing the intercepts. So this will be 2 equals to x plus 1. And so this will be x plus 1 equals to 4. X equals to 4 minus 1, 3. This is 3. This is the graph of f of x equals to minus x plus 1 plus 2. So this is the graph that you get. You can put your line of symmetry there at no, this is 1. This is 1. Yeah, the line of symmetry is at 2. Like that. So that is the graph there. Alright, so in summary, you need to memorize these transformations and be able to apply them, apply reflections, stretch and compressions and shifts. And then here is a practical problem. So I'll leave this one as a homework. Leave this one as a homework. All right, thank you very much. Let's meet on the next lecture on quadratic functions and their properties.